Alright, how are we guys? This is Paul and Michael. We're talking neuroperformance, and last time I spoke we just introduced what the concept of neuroperformance is, and I've been doing this stuff for 3 years now. I've been a physio for 16 years, so pretty good idea of mechanics and functional anatomy and that sort of stuff. And really at the 3-year mark, back when I started this neurology thing, it really started answering for me a lot of the questions that I had for, you know, why things weren't working and why things weren't getting better. And I realized that I was looking at the muscles and the joints and the physiology and the knee, for example, without really any too much consideration about what controlled the muscles around that knee. And of course, a lot of it comes back to, if we trace it back to the peripheral nerves, up to the spine, up through the brain stem to the cerebellum, right up to the top of the brain, when we get a lot of sensory information. And then of course our motor cortex, which is all about how we're moving. So that really opened up a can of worms for me, and ever since then I've not really looked back. And I want to, I guess, educate people out there about how we can understand the brain more to understand performance better, and rehabilitation. But performance is what this is all about. So today, as I was saying, we're going to talk about the frontal lobe, which is that green guy at the front here. So this is the brain, and this is a cross section of the brain on the right. Okay, as we can see, we've got the cerebellum here, the occipital, parietal lobe, and at front here we've got this frontal lobe, which is actually divided into 3 parts here for us. We've got our motor strip and our prefrontal cortex. Okay, so on the inside here we've got all little bits and pieces of the inner part of the brain, and in here we've got more primitive parts of the brain. Okay, so this is a brain stem, and that will go down to the spinal cord. And when you think about the evolution of the brain, right back to whenever humans began, who knows what was going on back there, whatever we were. This part in the middle here was the part that was developed first. Okay, and a lot of mammals have this part of the brain, right? So this is not unique to the human. You know, a lot of the functions and anatomy or neuroanatomy that lives in here is hardwired and lives in a lot of different mammals, and that's the balance system and the fight or flight response and the autonomic parts of the nervous system that live in here. But as our brains have evolved, okay, they've gotten bigger, thankfully, and this frontal lobe really is a more recent evolution of man, where we've grown space to account for this part of the brain that's really become our thinking part of the brain, our organisation, our planning, our problem solving, you know, the part that really separates us from a lot of other mammals. And the frontal part of the brain is really quite complex, okay, but if we can break it down here, we can really we can start with this pink part, and this pink part is really our motor cortex. Okay, so the motor cortex is really where we voluntarily start to send our information to muscles. Okay, so when we want to make a movement, motor cortex sends that information to the spinal cord and down to those motor units that then fire different muscles. Okay, so it basically sends the commands. And then we've got this brown part here, which is our premotor cortex, which is, you know, a lot of this stuff is still being studied, but they think the premotor cortex is where a lot of prediction of movement goes, and of course close to this prefrontal cortex, particularly on the inside here, we have what's called our frontal eye fields, and our frontal eye fields are responsible for our ability to scan or bring attention to things in our visual field. Okay, so voluntary eye movements, voluntary body movements are all very closely related through here, or come from a very close proximity. As we move out, then we're going to move from that premotor cortex and frontal eye fields more into our green part of the brain here, which is our DLPC, or dorsolateral prefrontal cortex, and that part of the brain there is more getting into our executive functions, and we can think of the ability to think of things on the spot. So mental flexibility, our ability to recall things. You know, if someone told you a series of letters in a row or numbers in a row, would you be able to recall that? And those more higher level functions of the brain, which are really more planning, predicting, problem solving, organizing. And then of course we've got our orbitofrontal cortex at the bottom here, which is sort of close to where the smell part comes up into the brain. So it's really about how well we can pick up smells, and also about social behaviour and the ability to inhibit certain functions of the brain. So inhibition is almost just as important as execution. And when you talk to people that have had brain injuries, or you research people that have had brain injuries, particularly to that frontal part of the brain, they find it hard to inhibit. So inhibition can be on multiple levels. You can have inhibition of emotions, and so the inability to inhibit an emotion might mean that you tend to rage on a little bit quicker, or the inability to inhibit your movement. Okay, so people that are quite flighty or stressed will have this inner part of the brain, which is a little bit more your fight or flight center, if you like, dominating over this frontal part of the brain. And we're not inhibiting movement, you can see actions become quite erratic, and words become quite erratic and irrational, because this guy is our rational brain, and this guy is our self-awareness and our concept of time. And like I said, a lot of human type functions happen here, and we consider this to be our mind. So frontal lobe got a lot of stuff going on. When we talk about performance, it's the ability to think on the spot, you know. And when we talk about what makes a good athlete, you know, it's not just all about our physiology or our genetics and our body type. You know, a lot of it comes back to what's in our mind, how well can we control our thoughts, and how well can we control this guy, our autonomic nervous system. And you know, a lot of that comes back to frontal lobe. So in summary, we're talking about movement, voluntary movement. We're talking about planning, predicting. We're talking about thinking on the spot quickly, organising, problem solving, recalling, and our ability to inhibit, and our eye movements and our ability to bring attention and scan accurately and quickly to different things in our visual field. We're also talking speech, and we're also talking fine motor control of the hand. This guy is huge. So if we're ignoring this, we're not looking at this part of the frontal lobe, I'd argue that we're not really covering thoroughly what it takes to look into performance enhancement. So let's start and stop there today. So frontal lobe, hope you enjoyed that. Next time we're going to go into a little bit further back, which is the parietal lobe, or the part of the brain that takes a lot of sensory information in. Hope you enjoyed that. Thanks for listening.